Hello everyone. So let's visit today's problem of the day. It is partition array such that maximum difference is k. Let's see what the problem says. You are given an array, an integer array nums and an integer k. You may partition nums into one or more subsequences such that each element in nums appear in exactly one of the subsequences. Okay. Return the minimum number of subsequences needed such that difference between the maximum and minimum values in each subsequence is at most k. Okay, so we should just return the number of subsequences and not the entire subsequences. Okay, subsequence is a sequence that can be derived from another sequence by deleting some or no elements without changing the order of the remaining elements. Cool. Okay, so for this question 36125, we can partition nums into two subsequences 3, 1, and 2. So maximum would be 3, minimum would be 1, 3 minus 1 is 2, and that is less than or equal to k. Okay. And over here, maximum is 6, minimum is 5, 6 minus 5 is 1, which is again less than or equal to k. Okay. Hmm. Interesting. So, again, see, I think we are supposed to select every number in the nums array over here. So honestly, it doesn't matter how we select elements. I mean the order in which we select elements. So we are only supposed to keep count of the track of the max element and the minimum element. So I'm thinking of sorting the entire array once. So it will be 1, 2, 3, 5, 6, and so I'll start. My minimum element would be the first element, and as I traverse, once I reach an element whose minimum element minus the maximum element would be greater than k, that would be one of my subsequence. And yeah, at the end I would be left with the let's say answer is 2, I would be left with the answer is 1, uh, and then I'll have another subsequence left, and that would also be included in my answer. Yeah, so I think that should work because over here, so yeah, it basically means the same. So I think it should work. So let me start coding. So I'll initialize n as the len of nums, and I will sort it over here. Okay. And now I'll have to keep a track of two elements. One is the minimum element and the maximum element, right? So my minimum element initially would be float infinity, and the maximum element would be negative float infinity. Okay. Now I would traverse through the entire array once, and I'll check if I'll check the minimum element. So minimum, basically I should find the minimum of the mini and the current element, right? So it would be minimum of mini and the current element, which is nums of I. And my maxi would be, it would obviously be the maximum of the current maxi or the nums of I. Okay. Now I have the minimum element and the maximum element. So if the maxi element minus the minimum element, if it becomes greater than k, only then it's an issue, right? So I'll also have a variable known as count over here that basically counts the number of subsequences, and it will be count plus 1. And once I've got this right, uh, then both my maxi and the mini variables would be nums of I, because let me give you an example over here. Let me take this example itself. Okay, so if this is my array, and after sorting it becomes 1, 3, I mean, sorry, 1, 2, 3, 5, and 6. So I would see the condition satisfies still here, which basically means my minimum would be 1 and my maximum would be 3. And then the next maximum would be 5. So 5 minus the mini current mini is 1. So which is obviously greater than k, which basically means now my next subarray would start from here, right? So I will have to set the minimum and the maximum element to this number. So let me remove this. And yeah, I can set the mini and the maxi to be equal to nums of I. And yeah, I think that this should work. And at the end, we'll have another subsequence left. So we'll have to return count plus 1. Okay. And yeah, I think that's it. And it should work fine. Let me run it once. Cool, it did work. And I think we can optimize, not optimize. Basically, I think this is not uh, necessary. I mean, it is not necessary to find the max of maxi and the nums of y, because since the array is sorted in ascending order, every time I encounter a nums of I, it will obviously be greater than the current maxi. So I think this can be nums of I over here. We are basically reducing the compute of another maximum. I'll run this again. Okay, it's working. Let me submit it now. Okay, fine, works. So yeah, that was today's problem, and the time complexity would be O of n log n. The reason being we are sorting it over here, and then obviously it would be plus O of n, which again boils down to O of n log n. So I think this is not required. So our final time complexity will be O of n log n due to the sorting over here. So yeah, that was today's problem. Let me know if you have an efficient approach to this. Thank you.